engineering your future. You're all engineers in some way. So you are engineering, you basically have to think about how you're preparing yourself to go to the world. But you have to think of it as engineering your life, because you're preparing it to go to the world. Okay. So the way to do that is for me to share with you how I started. Okay. So that's me in school. Long time ago. I was young also like you. Okay. So that's in St. John's. I think you can recognize which one. That. That's in Kuala Lumpur when I was about 15 or 16 years old. Then I went to university in London, Imperial College. Yes, my friends, just like all of you. This is my first job. How did I get my first job? Actually, very similar to you. I don't know about what's happening here, but in the UK, the companies will come into the university and introduce themselves. And then they ask you to apply, or you can apply. So I applied when I was at university, and after a while, I got a job in, this is my first job. Where is it? Scotland. You can see it's very cold. Who's from the UK? Anybody been to the UK? Which part?
London.
London. Okay, so I was in London doing my degree. Go to Scotland, it's even colder. Okay. So that's my first job. What did I do in my first job? It's in Edinburgh. I started off as an apprentice. So apprentice, for 1 or 2 years, we were working together. These are all the same batch joining the company. So we went through and did the training, we did a lot of, we went through and did different parts of the company to understand. The company was HP. Hewlett Packard. Anybody know HP? Good. Anybody use HP computers? Okay. And that's my first job as a production engineer. It's really cold. Everybody wearing sweaters. So that's in the production line. What I had to do, they basically said, okay, this is your job, you don't have a choice, you come into the company. I was doing production, these guys were doing R&D, some of these people do something else. So we came in, you do this, okay. So that was how I got into production. I didn't really choose. But I found out later why I got that job is because of the project I did at university. That final year project I did at university was to do graphics, computer programming, creating software for colors at that time, how to do CAD. And so they wanted someone who already understands software, but more importantly, 3D, CAD. Okay. So that's how I got the job, because I did not choose production engineering. So that was one of the most advanced computers. It's the 2832 computer, because it's a graphic screen. You see the screen is landscape. Most screens are not like that. So it's got a lot of graphics inside, built in, and my job was to create some software for production. So that's how I got my first job. I didn't plan for that. I just went in. I'll come back to this story later. I want to show you this is what happened. So what happened after that? I became an engineering manager. You look at all these people, I'm the manager. Okay? Because now, because of what I did, the company wanted to expand. They wanted to expand from Edinburgh to Bristol. So they said, you have that experience that we need. Would you like to come to Bristol? So I looked at it and said, what is this job? Oh, it's making disk drives. Disk drives are mechanical. I'm an electronics person, so I said, no, I don't want to go. Because in Edinburgh, in Scotland, I was doing electronics. I was doing CAD/CAM. So I said no initially. But the manager who was in charge then said, okay, I understand, we respect you. So one day, one of somebody else was going to go to Bristol, and he said, why don't you come over, just have a look. He said, come and have a look. So remember, it's Scotland. Scotland is up there. Bristol is next to, on the same level as London, right? So I said, wow, that's my first business trip. And I don't have to do anything. Okay, sure, take 2 days off. And went and took it, and then took the train, overnight train. In the morning, the train doors open, I looked at the sky. Wow. Blue, completely blue and warm. You compare with Scotland, cold, blue and warm. The next 2 days I was there, it's like that. I decided, okay, I'm moving. So I decided to join, and I was now, with my experience, which is only 2 years, I became a manager. Why? Because they needed, so it's an opportunity. So my job then was to create and transfer the production line. That's the production line. To transfer the production line from the US to bring to the UK. And we set it up. So this team is the production team. You see the factory not complete yet? We're just starting. That's the factory that's complete. So each one had a role. The person who came with me got the production supervisor's job. I was the engineering, manufacturing engineering job. And so we worked very closely. We did and built this. So you can see that came by accident. And even accident, I said no. And it's only because the sky was really hot. So what happened after that? The division then wanted to create a new product. They said, okay, E.T., would you like to manage this new team and design this stuff? And this is a very pioneering product. The world never had this. So I was asked to go investigate a replacement for tape drive. The replacement for what? At that time, people used this tape. It's a half-inch tape, very big one. If you all watch old James Bond movies, you see the big tapes going round and round. That's half-inch tape. My job, our team's job, was to create something so small, here, create from scratch, and create a product. This is the product, and launch it. And those two people next to me are my engineers. This one is an engineer. He's a hardware engineer. His name is Atkinson. And this is John. He's a technician. Okay, so you look at it, it's kind of a funny picture. The shortest guy and smallest guy. So that was to show this, the launch product, the photo for launching the product, to say, compare this with that. So this size has enough storage to cover all these tapes. This guy is holding all those, he's holding the same capacity. So I didn't choose that. I was it. People said, the managers, would you like to do that? Okay. So that was basically creating a whole new category. This product became very successful. Today, I don't think people use backup so much anymore. They're still there. It's about 20 years ago, more than 20 years. So after that got launched, there's a whole set of next generation. There are 7 generations from this first one. I wasn't involved in the 7, I was only involved in the first one. Because then I got involved in another project, which is next door in HP Labs. And that was creating a new industry standard, IrDA. IR, infrared, DA, data association. So HP then looked at how do we create a new standard. Why do we want to create a new standard? Is because we wanted a wireless way of transferring data. So I was asked to see how we can create that into industry standard. So we had to go through many, it took 18 months to get started. So we had to go to Japan, to Europe, to explain. I wasn't the only one, but we had a team. That picture is we had to convince Hitachi. We had to convince Alcatel. We have to convince Nokia. And one of the most successful, have anybody heard of Palm Pilot? No? Just to show, at that time, this is a long time ago, 1990, 91, 92. Okay. You can see different products, people were creating different applications, because the idea here is, how do you transfer data from your camera to your phone? Today we have Bluetooth. Right? What was before Bluetooth?
Wire.
Wire? Yes. But before, so what we were doing is, how do we replace wire? And that wire is what? The EE people, computer people, what was the wire at the time? RS-232. Today we have USB, but that was before USB. It was after RS-232. Anybody know what RS-232 is? You don't have to know it now. It's all USB. Okay? So we said, how do we replace a wire? And how do we do it that it is cheap enough? Because Bluetooth at that time is RF. RF chips were very expensive. RF chips, one chip, just the chip alone, without the electronic, the chip alone is over 100 US dollars. One chip. So can you imagine putting that chip here? You cannot afford. How do we make that happen? But how do we make it cheap enough so everybody can use it? Remember, no Bluetooth. So what is the cheapest thing at that time? So we looked at it and we said, remote controls. You all have aircon remote controls, right? That's infrared. Infrared and aircon controller has one, and it's very cheap. So we took that idea and made it into a standard. That's why it's called infrared data. Because the infrared that you have on the aircon and other things, the data is too small. You cannot transfer a file. You can transfer instructions. Okay, you think about transferring instructions. But if you want to transfer a file, it's going to be very big, and the speed is not high enough. So that's really where the thinking of infrared data association comes. We said in HP, we said, how do we come up with something that is cheap, that is wireless? That's the requirement. Because we know the only way is to do wire, but to do a wire, what you have to do? You have to have a computer, right? And that time, the only computer you can use is what? Windows. Well, at that time, it wasn't Windows yet, it was MS-DOS. So if you want to transfer a picture from your camera to your computer, you have to use MS-DOS. You have to get a wire. You have to make sure that the camera has an interface with the plug. So you can imagine all that is very complicated. And if you don't have a desktop, at that time, no laptops. If you don't have a desktop, you couldn't do it. So the thinking that we had was, how do you make it without requiring Windows, without requiring a desktop, without requiring a computer? Computer science, computer engineering people, right? EE people, right? This is the problem. So you now have to think the criteria. The criteria is to remove wire and to make sure it can be implemented in a chip device. And to implement in a chip device, you have to have a very simple protocol. Okay, because science people, you know what I'm talking about, right? Protocol. Okay, so you now have to design the right protocol that can carry a large file and fast enough. At that time, the highest speed was what? 96K. If you want to send a file, how fast do you need to be? So we had to now calculate and say what is the optimum, what is the normal size of file. At that time, maybe not even 2 megs. Oh, say 1 meg. Right? And how long should it be for you to transfer and wait? How long can we wait? How many seconds? 2 minutes?
More than 10 seconds.
More than 10 seconds? Can you wait for more than 10 seconds?
No.
Okay, so now this is the kind of thinking you have to have when you're designing something. So we say it should be 2 seconds. Press and do that. Of course, you have to assume it's 1 megabyte. At that time, 1 megabyte is very big file. 2 seconds. So, what was the speed? 512. 512? RS-232 cannot do 512. So we now have to make that infrared link fast enough to do that. Then we said if we implemented it 512, it's no good because within 2 years it's going to be higher. So we actually had to think through all this and curate it. So when we created that, that's how we got 200 companies to agree, because they see the picture, they see the vision. They said, yeah, I want this. So we had Sony, we had Alcatel, we had Hitachi, we had all the consumer companies, Casio, watch company, phone, they all agreed. And we got that. Because of that, after a year, 2 years, over 2 billion devices implemented this. Everybody is infrared. There was before that time. So once we had that, the price of Bluetooth went down. When it came down fast enough, okay. So this is an example. This is a Palm Pilot. Palm Pilot in the UK use this and put it in everything, and you're able to transfer infrared. So most successful. And because of that, a company called PayPal, who have heard of PayPal? That company said, what about transferring money? That's actually how PayPal came about, because of infrared. They transfer money, and then that's how it. Okay. Other applications came up. We had many failures. This one here is even cooler. It's a handheld scanner. Then you print it, send it up to print. Okay. You scan everything, then you send it out to print to another printer with infrared. So you can just, this is my document, print. Okay, 18 seconds. Okay. All right? But it was a failure. But that failure, we took that chip and put it in a mouse, and that's what is in today's mouse. So that is possible now. Okay? So it's all about engineering, it's all about thinking, it's about problems, how we solve problems. So we come to the most important part now. What does it mean for you? How do I prepare? You are in engineering. Okay, this is very important. So, first question you have to ask yourself, we are all here, you need to pass, you do your degree, you do different things. You have to know what you want. What are you passionate about? It's not about a job, it's about passion. My passion was to solve problems. I was really excited doing graphics, and then somebody said, I need you, come. I was in Kuala Lumpur, and they gave me a ticket to call up and said, call my mother. My mother said, I do not, it's an Englishman, come on. And they called and said, we know you want to be in Malaysia, but if you want to join us, we already have your ticket in KL, American Express. Pick it up, tell us what flight you're coming on, we'll take care of it. Okay? So, what are the things you want to solve? Is the first question. Now, that's the recruitment process. I'll just go through this very quickly. Stefan has helped put together a little handout that I think you will get access to.
You can send this to send the QR if you like.
It has more details on this.
To the group.
So it's about
Yeah, if you like. No, it's okay.
applying.
We can.
In there, you will get shortlisted. In my case, I applied when I was at university. Then they offered when I was in PS. Okay, I came back from UK already. They called me because they said I needed this too. It's about assessment, interviews. So in my case, the interviews happened when I was in the UK. Assessment, and that's when the offer came. Okay, so those are the steps that you have, but it has to start with what you really want. The answer, if your answer is, I want a job, then you might find that that job might not be the right one for you. That's right. But if you find this is what I'm passionate about, you look for and go after that, then you'll find that you are developing all the time. Next part, the process. Okay, go back. Okay, same one. Sorry. Okay. So you want to now look for what are where the opportunities are, how. So there are many things you can do. You can look through. I think it's about the benefits. You can ask your friends, your social media, LinkedIn, so on. So I won't need to go through all that. I think you all know about it. The more important part, I think, is why you're here. What you always look for. Okay. Really is a strong technical foundation, which means learn everything you can. You are here to do a degree, you are here to learn something for 3-4 years. Make sure you understand it, because only when you understand and they find out you understand, you will accomplish it. Just because you go to university doesn't mean you go to job. You have to show what are they looking for. See? They know you're fresh, so they can't expect you to have a 20-year experience. They can't expect you to have a 5-year experience, it's just graduate. So they know, but they need to know you know the basics. Okay? And also they want to make sure there's minimum handholding. They don't need to kind of tell you what to do, how to do. You have to know the fundamentals. And you're looking for people, because they don't need to handhold you, you will find out for yourself. You have yourself learning. Don't think that after you finish university you don't need to learn anymore. I've done it. That doesn't work. Today, everything moves. What you're learning in university, 6 months after you graduate, maybe irrelevant. Of course, if you have some internship experience, it's a good thing. And exposure to industry tools at university, what you're doing now. Then about those. At university, I think we were very impressed our second round. We've got some fantastic equipment that we have. Use and learn about it. It's not about passing exams, it's about what you learn. How you learn. The exam, the purpose of the exam is to indicate to the university that you have learned. If you just think, I want to pass exams, you don't have to learn. It's a certificate. Then I'm afraid companies, when they interview you, they will find out when they interview you. Okay? So how do you give them information before they interview you? How do they find out? How do you prove you're curious? They want people who are curious, natural curiosity. Self-learning. Okay. Who knows how to use ChatGPT? Sure. People who did put up their hand, do you know? Good. Did the LOC teach you? You cannot wait. Same thing. Learn for yourself. There will be other things like that. Okay? Not just that. There's a whole bunch of other things. Okay? This one here is really important. Communication. Communications is about not just a presentation. Communications is about how you interact with your boss, how you interact with your colleagues, how you explain why you think it's wrong in a way without offending people. Because that's called teamwork. If you don't, you need to be able to work with other people. Okay, so communications and how you explain yourself, how you present, how you are in a meeting. When you all do project work, you work together, right? All of you have done project work in more than one. The whole team has to work together. The ones that know how to work together fast will get the best results. How you communicate. Okay. So project work is just a starting point. When you are in a company, the people who know how to do that will be recognized by the boss. This guy here. Every time we have argument, he knows how to move it along. He knows how to get people to agree. That agreement helps the company. So what do you think? If I'm the manager, how do I see you?
It's good.
Good?
Yeah.
Valuable. Why? Because he's able to make sure the thinking process moves fast. Progress moves fast. So he's valuable. He's more valuable than the others. But it's different value. They may know different things. But you're able to move things along. So what is that characteristic? Management. Management means managing people, activities, tasks to a goal. That's management. Management is a manager. There are many managers who are terrible. Okay? So management is about how you get people along, and the way you do that is communication. It's not about saying, I know it's right, you're wrong. That's not it. You might be right. But if you always offend people, nobody wants to work with you. That's not communication. Can you explain your work to non-engineers? That includes the manager, by the way. Includes the CEO. How do you present the complicated? Okay? So, soft skills are important. Teamwork, problem solving, adapting. So the best place to practice is actually at university. You work with them. So, the summary here is how you solve problems. Right? Because when you're in a team, everybody will know something. You're able to bring all that together to solve the problem. That's important. That's why in university, that's what you're doing in teamwork. Okay. All right. So, we're all looking for jobs, right? The list of employees today who are the movers and shakers in the business. I don't have a picture to explain that here. But today, with the help of Stefan, he's going around the industry and he knows what this. So I agree with that. Penang, Klang Valley, Johor. Okay, we have to go back to Ethiopia. That's it. Okay. That is on electronics. That's that's really the center ecosystem for that. Tech Valley, I think you know. Tech hubs, R&D, there's a lot of companies in there. Johor is a big area coming, and they go manufacturing and data center. Probably all the data centers over there. But this point here, we want to share with you. Don't just focus on multinational companies, because the local small companies will give you a wide experience. When you're at a very large company, which is Recruitment, you are put into specific jobs because we have only 5,000 people. And then 5,000 people, sorry, you're going to do this, and you're going to do that. Okay? So, for example, in a large company, you might have QA, quality, reliability, failure analysis, design. So, if I'm doing design, something wrong, I go and see the failure analysis person. That means you don't know how to do failure analysis properly, you don't know how to do QA. Because you're focusing on R&D. In a small company, everybody does everything. So you learn in a different way. Okay? So it's your choice, you decide. I started out with a big company, but I got an opportunity to go around in different ones for 20 years. I had 7 different organizations. I was in manufacturing, I was in R&D, I was in strategic marketing, I was in all kinds of areas. Almost every area I was involved in, except HR and sales. That's 20 years. I don't think it go faster. So that's advice for you to think about the difference. So what are the hard issues? I think you all can recognize those in Malaysia, and actually happening around the world too. The Middle East countries, Arab countries, GCC, the Gulf countries, semicon, IC design. However, you cannot ignore automation, AI, all these other things, because when we look at semicon, we're not just making chips, we have to make the equipment to make chips. Okay, so there is a list, a set of things that you will be involved in, because there is no such thing as just, oh, I do the equipment. You have to design equipment, you have to build the equipment, you have to do some of the most advanced things. If you don't have the equipment, you cannot do the semicon. Okay. Come back to that. I have questions if there are finished. Okay. All right. So, I give you the list of hot jobs. Now, we also need to know trends change. Okay? You really need to know what you think is hot today. When you graduate in 2 years' time, will you not? Okay, so that's why you have to be continuously keep up. And you have to now continue to know what is it that you're interested in. Because if you're just say in university, you find a job. Good luck. Because in 2 years' time, who knows what's going to happen when you die? Who knows what's going to happen with geopolitics? Oh, I'm aiming for this job. So when that job goes away, or it evolves, what are you going to do? No, but I went to 4 years, I did all this, I got a certificate. I got this from a very famous university. It's not. They'll be looking at you when you don't need to be here. Remember all the things we said? Do you have those skills? Do you have those characteristics? Do you know what you want to do? I want to see whether you can help me. But you want a job? Sorry, I don't have that one. The whole world is doing that today. 20 years ago, maybe not, because technology doesn't move that fast. Today, every 6 months, ChatGPT wasn't here when you started the course, right? When you started this 2 years ago, ChatGPT wasn't here. When you finish, I don't know what's going to happen. 3 months ago, we didn't even hear of DeepSeek. Right? Now everybody's talking about agentic AI. You know what agentic AI is, right? Check. Hello. Okay. Oh. Year of tariffs. April 2nd. Not everybody's trying to figure out, should I move, should I not? So you can know what is the impact going to be in 5 years. So even if you get the job you want in 2 years, in 5 years everything changed. Your degree is not going to work unless you continue upward. What else can happen? Okay, so that's the key you want to think through. It's not about jobs. It's about what you want to do. Because you are the asset. The asset doing the right thing, people will hire you. Okay? Alright? So this will not change. What is it? This is a supply chain that I put together many years ago of how electronics, computers, robotics fits all of it. But it's true. At the end, we're making a product. End user buys the product. Think of any product. Phone, big machine, or refinery. Yeah. But to do that, you have to have an idea. You have to now do market assessment whether the idea will sell. Phone. Okay. You have to do R&D, prototype. That's where E&E comes in. That's where computer engineering comes in. This manufacturing comes in here. QA. So this part here is product development. This is manufacturing. This is not. You can't just do this and just, can you please watch this? We're going to look at it and go, no. It doesn't fit. Yeah. So you have to do market assessment. So this, every company that sells anything including clothes, watches, buildings, has to go through this process. Along the way, somewhere in here, I need a new chip. This phone has probably 20 different chips. This phone's chips will be different from that phone's chips. Where do you get those chips? You start with this idea up here and say, this watch will have a chip different from an Apple Watch. I need to create a chip. Boom. A new team designing a chip. They then have to do semiconductor wafers. fabrication, chip design. This is the IC fabrication. You get the wafer, you cut them up, you go into chip assembly, you need machines. Then you create a chip that goes into the production line that makes your watch. Because this is the watch or the phone or the fridge. The chip is a separate. So every one of you in this room will be involved in this in some way if you go into this. Even if you don't, you say, I'm going to marketing. Oh, I'm going to sales. So what? Okay? So this will never change. So your issue is, what value do you bring in to this channel? They don't need to give you a job. You run a company here, I'm looking for the best person for the job. I'm not giving you a job. I'm looking for someone who can help me do this. So understand that. Okay? So this will never change. What it will do, it might go faster. They might have new technologies to make production better. Why? Because you use AI to do QA. Maybe you use AI to do procurement. Maybe you use robotics to speed up. You use IoT, digitization, so that you have the lights out. So whenever someone says out there says, oh, robots are going to replace people. Yeah, but who's going to develop the robots? Who's going to maintain those equipment? That's why you're here, right? Okay. That's the story that we need. It will not change. This will not change. So, what is really important? Nobody owes you just because you know, because of the certificate from whatever. So, big deal. Other, big deal. Attitude, knowledge, and how you tell the story. How you explain. What are the important things? People want to know, what did you do? Oh, university. Yeah, I don't have any work experience. So how do you explain that? That they need you. They need you from a university, from APU. How do you explain it to you? Of course, don't say things you don't do. That's integrity. Okay? So, all of you know STEM, right? Science, technology, engineering, and maths, STEM. Today's market, STEAM. That, we call it the arts, but actually it's more than arts. All the holistic skills. So the way I look at it, think of A as the articulation of STEM. How you articulate what you know in STEM. If you don't know how to articulate, you don't know how to explain, you don't know how to communicate, your STEM is not going to succeed in the future. So you have to explain. Okay? And the explanation starts with how you write your resume, how you write papers, how you interact with people. Okay? So that is what I want to kind of explain to you. Okay. So, this is another way of saying it, what the employees need. One, multidisciplinary engineers. high-grade skills with emphasis on soft skills, like communication and an interest in continuous learning. That's the most valuable new staff member. So, what it means is all of you have training. I found it on that. In some ways, it was coincidence, it was accident. Things happen. I didn't say I want to create a new industry standard. I never said I wanted to create a new industry standard. By the way, I created 3 industry standards. Because they asked me, hey, can you do this one also? Yeah, as we say in Mechatronic startup, so right? Because of that one. So they ask you to do other things. Now, this is the last slide. So now, how do you do? What do you do? How do you do it? How do you build your brand? This is the important thing to social media. Who has their own social media channel? TikTok, Instagram. Don't be shy. You don't put your hand up. You're the one that's looking. Why do you do it? Why do you do it?
Your own branding, and you sell your image to others.
Okay. What kind of things that's in your channel then?
So it's not really a channel, but something like LinkedIn, and you sell yourself.
Okay. So that now, yeah, good. The thing you now need to think about is, what are you selling? Okay, some people sell what? Right? Some people do that. I'm not saying do. But when you're able to do this, what is it you sell?
People who need people like you will look for you.
Yeah.
Attract.
Is that what you're doing? So if you're now doing, you're here thinking you want a job, then you need to align your message on social media to build that brand. If you're here looking for a job in 2 years' time, what you're doing this? In 2 years' time, you're going to do what? Oh, morning. Yes, come. So the way to do that is you have to start thinking what you really want to do. My slide, 6 slides ago. What is it you really want to do? You want a job? Okay. Then what are you doing? Unless you want a job at this stage. Right? So building your brand is about building a portfolio. So in effect, this today is a very important element of your resume. Your resume is your brand. Compared today, you send in your application. It's all AI, nobody reads it. But social media, they see you first. Then they go, oh, hey, you see this guy. Oh, so it amplifies. Right? So what you want to do is you want to think, and one of the most important is this one. Today, LinkedIn. Stefan is a recruiter. In other words, what? So, yeah. Maybe that's what. So, how do you build? What effect, what image do you want people to have? Really focus on what you want. So back to the slides I had earlier. What problems you want to solve? What solutions you want to focus on? What are the things that you want to be good at that people know you that they will give you a job for? Okay. 30 years ago, I didn't know people wanted CAD exercise in my last year, and that's what they wanted. And today, CAD is what? Graphics, GPU, everything that's in GPUs, in NVIDIA, the foundation of the kind of work that I was doing. Because that's how we do today. You know, all the games, role-playing games, and all the rules are all to do with graphics. Okay. So, this is my last slide. I give you an example of what I am as an LinkedIn. Very happy for you to connect my LinkedIn. Just scan that thing. And so, how you build yourself, you know of you. And then you just be consistent. And that's what people do. They see, they want your opinion. Or they're curious about you. Okay, so with that, I finish and open for questions.
I got a question. So, besides all the soft skills that you listed, like teamwork, all that, are there like any other skills or habits that you think, while we still have the time and the luxury to do so, that we should pick up before going into an interview or starting a new job? Any other habits or skills that you think, while we still have the chance, we should pick up now, like a new language or something like that?
Stefan, can I answer that question?
That's a good question. I think they are very interested in problem-solving skills, which we listed. I know we listed that already, and you're asking for other skills to pick up. But problem-solving comes to my mind because the customer is serving their own customers. Every single company has their own customers, and basically, companies exist to basically make a profit, to make money. And I'm telling you this because you need to come in and you're part of the problem-solving equation for them, right? So your ability to be very interested in their problem, what they're trying to do, and do your job really well will determine how well you actually do. So that's very important. I would say one thing we didn't mention would be things like to be selfless. To be selfless and to be open to helping others. Because once you start to help other people in the organization do their job better, you start to develop influence. And once you start to develop influence, people will start to notice you. And then it kind of keeps spiraling. So I think we did mention selflessness as well, and willingness to teach others. And that's something to be mindful of. And I think you can develop that here, when you're working on coursework or projects together. Standing up for your peers and your teams, supporting each other to complete a goal, all that can be carried over to work. And just to finish up, no one will ask you to help anyone. You know, people are obsessed with their own job. They just want to do their own job. They usually want to go home. But you can really differentiate yourself by stepping out of that and helping others. And usually people that take the extra mile and they think about their goals and what they need to do to help the company, those are the ones that get noticed quickly and they start to grow. Because, you know, CEOs and owners of companies, they want those kinds of people to progress, do well, because they want to depend on those people. So I hope I answered your question.
Yes, thank you very much.
Very long-winded.
Okay, next question.
Stefan, just now you mentioned you set 3 industry standards, right? That's the hardware standard.
So basically, this drive or encrypted drive, but an encrypted drive, these have a standard because you want to put that in that in. So that's the standard. The other standard, I mentioned it actually, but I didn't say it's a standard. It was the DAT, because it was a new, completely new technology. Remember, everything was this big, and we came up with this thing. So it has to be standard. So we need other companies to be able to support it, and we actually have to create other competitors because nobody wants to buy it. Except that. Okay, so that's the solution. Okay, other questions?
Experience.
What are the challenges?
Yeah, that you face personally.
One of the biggest ones is getting customers used to the environment. Because you end up working with different people. So I'll give you an example. We were trying to get a standard for the infrared standard to everyone. So we could not afford to have another company come up with another standard. Because we already managed to get Apple, Motorola, we managed to get Philips, but we were really concerned with the Japanese. So one day was that picture there is actually the result. The struggle was, I don't know Japanese. How to move to the Japanese, really hard. So we were struggling, we were trying to figure out how, basically it's different cultures. So luckily we had Sony on our side. But Sony also said, we can't move with those guys. So can you please set up a meeting? So we had to, so this part of the thing that Stefan mentioned about teamwork. You need to have people trust you to introduce even their enemies to you. Even them. So I said, okay, sure, we need to, no choice. They're like enemies. So on the day before the meeting, I said, Nakasa, that's the problem. You know, I'm foreigner, I cannot do that. Why don't you have that? I would be there. Have to speak it like that. Why don't you speak in Japanese? Easier, right? Then he said, answer. He's the English. Huh? Right. They speak English. So you have to have that kind of rapport for them to come down to that level of relationship that's good. So you answer. You speak English, you speak English, we know what is it there. Now I'm confused. This is because in Japanese, there are 10,000 ways of saying no when you don't know. That's why Japanese really, you know, they're all doing all this IT and nobody knows whether we are agreeing. So that was for me a huge lesson on how to get things together. Okay? So it's about communication, but underneath the communication is trust. Trust is belief that the person you work with have to trust you. And the person I was working with was telling me that his name is Rhamaroo. He is the inventor of policy. Impressive stereo. Okay? Good question. I can't argue with them what technical stuff is. So, communication is always technical because you know what you like, you just, I know what to do, I believe you. I'll do it so that we go. Okay? What else?
So in order to get into a position where you can work into a career where like your development is, for example, like industry standards and all that, would R&D be the most suitable career?
Not necessary. Not necessary. Because if you look at industry standards, and by the way, it's getting more and more difficult. In the past, there were no standards. Now there are standards all over the place. Getting involved in industry standards, there are kind of 3 layers. If you have a unique idea to the world, that idea will be based on so it always in engineering it has to be based on engineering. Why is this? So that's why I took a little bit more time to explain the characteristics of infrared. Yeah. And somebody said the replacement is wire. And this is exactly right. You have to know what problem you solve. The problem you're solving is always R&D. Second part is now you have to create the right standard to solve that problem. Many people go, it's really cool to get involved in the standard, but you don't know what problem you're solving, you're just going there to fight. Example, we have to work with Philips. Philips already has infrared. In fact, Philips has patents about the remote control infrared. So now I'll tell you a little story. And they have the patent. They had R&D done already. And they basically said, you use infrared in your royalty. And you know why we gave your house at least 6 remote controls? Think about it. Everybody has at least 6 remote controls. Correct? Why?
Royalties.
Nobody wants to pay Philips. So you create your own. Why you have 6 is because National, Panasonic don't want to pay, I'll create my own. Okay. Daikin will create their own. Sony will create their own. Samsung will create their own. Oh, I've got some extra buttons because I can do this. No salary. So that's one aspect. So the second part is how to now get people to agree. So that's the marketing part. Understand? So you have to now go to so getting involved in standards is a very big deal. It sounds sexy, it sounds fantastic, but actually it's not going to work. And I just give you an example of one of the struggles. I didn't talk about how we got Philips to do it. Okay, because Philips has, I've already got a standard, I want everybody to pay me royalty. You guys have this meeting standard, no, just pay me work back. The third level is many people don't really care. Many companies, like Casio. You got a standard, 6 companies agree, 100 companies agree. Okay, we'll just implement. Right. 5G, same thing. That's why the Americans are very upset. I didn't get involved in developing it, and so I'm really worried. Yes, I don't want to just go. So most people are in that level, this category, which is I'll just implement. Because if I implement, I can interact with everybody else who has. Nobody argues about USB. Nobody argues about Wi-Fi. Does that help?
Yes, sir.
So the thinking process of a standard has all these. Whereas if you're just designing your own mouse, you know, there's a very famous company in Singapore that makes the most expensive mouse in the world. Who knows? Anybody know? Hmm? Radiant, right? How much?
Up to like 600.
Up to 600 ringgit. One mouse. 20 grams. Why? Because they want to move fast. Okay? Huh?
You say the mouse that you're holding now is also cost 600 around.
Oh yeah, it's an extreme one, yeah. Okay, this one also expensive, yes. It's got, I noticed it's quite light. Okay, so if you're designing something just like this, you don't need industry standard. You just buy everything, put it together, and then you just make sure it's one. And the rest, like that. Just so as Stefan says, the company that employs you, they want your skill to help improve the product for their customer. So if you're working for Razer, they will want to see if your skills can help them make better product. Good question. Any other questions? Yes.
I know that you have a lot of experience in the engineering field and also working in various companies. So I want to ask, how do you deal with like failure, like launching the product and the products did not receive well into the customer? How do you deal with that?
Okay. I have a lot of videos. Okay. I showed you one video. How do you deal with it? Okay. So first, you need to ask yourself the question, when you're in this project team, what is your role? Okay. If your role is an engineer, your job is to come up with a really most advanced mouse. So your job is to do the project. Means what? Okay, I'm trying to find make sure 3,000 dpi. By the way, 14,000. 14,000 dpi. So your job is to do that. If that product fails, what is your value that you have to do? The value you added to it is how to make 14,000 dpi. Correct? So if it fails, because your track record is I did 14,000 dpi, nobody else did. You still leverage that skill to someone else who needs that. So never look at a failure as a failure. Look at the failure is of the business project. So the company spent 25 million making this new mouse. It didn't sell. Not your fault. You contributed to make 14,000 dpi to make the mouse launch. Your success was to allow the mouse to launch on time. Correct? So when you go out and look for another job, don't say the product failed. Say your contribution was to get latest technology, leading edge for this mouse. That's what people want. Right? So who's the customer? In that case, the customer is another employee. The customer for the mouse didn't like it. Nothing to do with it. Does that make sense? So it comes back to, if you're an engineer and you're doing a profession, what did you contribute? What did you do? Because the project manager is looking for someone, they were 8,000 dpi, and they are looking for an engineer who can do 14,000. That's what Stefan said. They just want someone to a project with them. Now, if there is something else, let's give you another. He says 40,000 for you. You say, yeah, okay, good job. Then you go find out. And it's just, you do your job, and you actually go to come. But, you gonna tell me what I can do? Would you? No? I would. This one, I don't think I can do it. That's what I would do. This is outside my scope. I need to do it. But you know I can do this one. That's what I mean by don't go for the job. Go for something you can be proud of. What you want to do, what's passionate. If you're passionate, say, my job is to do. If you're passionate about it, you will find you may not know how to do it, but your passion will drive you to do it. You, night and day, you cannot do the passion, right? You all have projects like that, right? Night and day, you. Then you find out, hey, I can do it. I discovered it. Hooray. That's when you get a patent everything. Right? So everything for engineering is about the passion and how you drive what you love. I assume you all here because you love it. Everybody loves accounting, finance, Rong. They all get the right class. Okay, yeah. So failures are only failures if you fool yourself. Yeah? It may take longer. Then you have to tell your boss, this project, we cannot finish by the end. That's when you use your communication skills. Yeah? You use your communication skills to explain why you need to know this. You have to explain a technical problem to someone who doesn't know. Don't just get frustrated. Yes.
I just wanted to say, you can look at it also nowadays, failure is a way of testing the product as well. Because you don't have interaction with the market that you're selling it in, or sometimes you have less. I shouldn't say that. Sometimes you have less interaction with the market selling it in. So when you launch the product and it's failing, it's actually very valuable information. So then they have different ways of dealing with that. They have product extensions, or they will have reverse engineering cases where they will take that, rip it apart, go backwards, and then they will figure out, okay, this part actually was really good, but then this is not good, this is why it wasn't bought, or this is why it doesn't stick. So they will try to find out areas that they can keep, and they will use for another product. They can also do that. I'm sure, like what was mentioned, all you guys play, well, I assume most people play some kind of video games, right? So you know how video games are being developed right now. It's community-based development. So people don't develop a game in isolation anymore and go, okay, let's build a horror game, let's release it. No, they don't do that. They have alphas and betas, and right? And then the community is a part of the product, which is a video game, right? So that's one way they manage the failure rates. You know, and then what's the response alpha phase? Oh, not good. They gave me 3 stars on Steam. It's terrible. Look at the responses. Okay, beta phase. Let's go. You know, and then they release. There's some games that are in beta phase for 10 years, 8 years, right? So these are all ways of dealing with, like, mitigating failure, basically. Just want to add that on. So if they said, oh, we failed and withdrew, they would never have made money. But I think 12 to 15% of some of the games, they actually only make a lot of money maybe 3-4 years down the line, right?
we spent on it? 45 million US dollars. You know how many we sell? 16. That's a very
5. 16 million. 16 5 or
16. 1/6. We couldn't sell it.
45 million.
This product, 45 million. So, this is the biggest failure I had. And so, the learning it, we did. We spent all that money. Because the learning I can share is, the user doesn't want this model. Doesn't work. Today, you have a camera. You have a documented picture done. You don't need to do this. Okay. So then we said, how do we leverage, how do we recover? We then said, okay, what can we use the sensor? How can we use the same sensor, the technology actually looking at what failed, and then looking at what are the pieces that can be used for something else. So, the mouse at that time was a rollerball. So very close. But this one here, what it is a light, and then it's actually tracking how far it moved 2 points on the surface. Right? That was the fundamental of the previous product. The fundamental is the sensor. So we said, okay, let's find a way to apply it. And we found another customer who wanted to replace it. And then we looked and we said, the rest is history. The customer was Microsoft. It was taking Telemos. Yeah, so always find different ways of learning, idea and project team, learn, and then the company project, then always do a post-mortem. So you go in, don't start blaming people. That's where it starts. Okay, good. Other questions? Really good question. That's an important aspect of engineering. Because it not only applies on the product, it also applies on manufacturing. It applies on other processes also.
Okay.
Other questions? I don't have any questions for all that kids. Good. Well, I guess sometimes we also say next step when you do a project. Okay, is this big? There's a difference. Prototype will be different because you'll be using huge tanks somewhere else before you build this huge thing. Questions from that side? I got questions here. Anything for that?
So if no questions, before we end, our guest actually made a summary for us. So you guys can scan this QR code to get a document.
So that's that. That's a 2-page handout that Stefan put together, some of the points.
Maybe you've been to 5 different companies within that 5-year period. Is it a good look if you go to the next employer? Is it a good look? Is it a good look? It's a good idea.
Okay, that's always a very good question.
Yeah, I can add to that. Okay, there's different ways to answer that. So I always say, because the people that are making decisions are the hiring managers. So there's usually a manager that's in charge of a job, and then the job reports to that person. Okay, and then next to that person is probably an HR manager that works together with them. So it very much depends on their personal beliefs and their personal opinions. Some people don't mind it so much. Other people maybe do mind it. They think it indicates maybe instability, right? Generally, what I notice in maybe European and Western markets, it matters less. And then by job function, it also matters less for software engineering. Computer science software, it matters less. For other functions like mechanical engineering, design, electrical, it matters a bit more. They care about it more. And then going back to Malaysia, generally speaking, most of the employers, 70% plus, they do care about the tenures. They're sensitive on tenures. So they prefer about 3 years plus continued tenures. They think it indicates stability, right? But there's no conclusive evidence in many cases that X amount of stability will result in X amount of tenure, right? So the best thing to do is you need to demonstrate to the employer very carefully why do you want to take the job. When you get to the offer at the end, why do you want to take the job? And what's going to keep you in that job for maybe 2-3 years, and just to be open with them. Like, what do they expect from you, and what do you expect from them? That's a good way to approach it.
Well, in this part of the world, the concern is what do you need next year? That's the concern. Wow, your track record, you keep jumping. So if you join me, you're going to jump, better not do. So it's your job to reassure that person. I was jumping around because there was a case, my mother was a family was like this. As long as there's a good reason, people will kind of go, okay, so circumstances have changed. Okay, I feel we better. That's why I say that. Yeah. The other part I would also say is, from my personal experience, for young people like you, it's better to change when early part of your career. If you go into a job and it's not the right one, move. Okay? Because no point staying in and then after 10 years, it was the right choice. You wasted 8. Okay? So that is a personal thing that it's better for you to kind of build that. But of course you have to be careful. That's why it comes back to what is it you want? What do you want to build? Because as you're moving, you are building something. If you're moving and you're not building anything, then it becomes a rolling stone. There's no roots. Yeah? So that's the one thing.
Yeah. You can ask yourself, is it what I'm doing, is it destructive to my career, or is it actually constructive to my career? If you're moving and then maybe people are taking higher salaries and things like that, but they can't hold down the job, and then maybe they start to go backwards or something like that, then it might not be good. If you're joining for a period of 12 months, having very high impact on your projects, you might be surprised. Maybe even the employer, well, in that case, the employer would mind because they would probably want to retain you, but they might look at it and say, well, okay, this person came in, even though they're here for only a year, they still have high impact, so I can accept that, like something like that. So it really depends on, and then they will look at trends, like your past 5 jobs. What ET was saying? What was your reason for leaving? Oh, why did you leave here? Oh, I left because I wanted more money. And then the next job, why did you leave here? Oh, I got another offer to take more money. So they will start to form an impression. This person is very likely to leave if somebody comes with a 5% higher offer, right? So they might go, it's dangerous if we consider this, right? So you just need to be careful of that. Yeah, sorry, somebody had a question.
Yes, so since a lot of technical skills can be gained on the actual field, okay? For an entry-level role, what type of like most important skills like you guys consider? So right now we can actually gain some technical skills, but how far we have to go?
So the theoretical foundation, like for mechanical systems or mechanical design or E&E, like the foundations there, E.T. was mentioning in the slide, the employer expects you to come with those skills. So basically like the logic and the brain, like they are interested in how you think. In how you think and what you've been doing, right? The most important thing to stress here is they want to understand how you operate. How you do things is a lot more important than what you have done actually. Because when they are paying for your salary, they are buying a set of skills to perform a certain job. And they're also buying your own methodology. How do you do things? How do you run? How do you think? How hard do you work? How much do you work? So they're paying for all that. They're paying for your time. So to answer your question, like product-specific knowledge, you can probably pick that up on the job because you will not know like what they're doing, how they're doing it. But the engineering fundamentals that you are learning here are very important. You need to be very sharp on that, with that when you go to interview. They might pull out theory, they might pull out some diagrams, they may want to test you, but it's more to see how you think actually. So you need to practice that. So that part you need to come with, and then when you go into the job, you can request for training usually, depending on the company. That's what I would say. Does that answer your question?
Yes.